so today we're going to be proving Book 3, Proposition 17. So the enunciation for Proposition 17 says something along the lines of you have a given point, and from that given point you draw a straight line, and then that straight line that you drew touches a given circle. So more specifically to this, we are trying to prove in this proposition that point A extends out to line AB, which touches circle BCD. So our givens are circle BCD and point A. As you can see, my points are kind of small, but that's point A, and then this is B, C, D for our circle. So the first thing that we need to do for this proposition is finish the construction of our circle because it's not finished yet. So we are going to start by finding the center of our circle BCD. So the center is going to be E. So E is the center of circle BCD. And the reason for this is Book 3, Proposition 1. In Book 3, Proposition 1 is about finding the center of a circle. So we are going to use E as our center, trying to make sure that it's decently centered. Okay, awesome. So then for our second step, we are going to connect AE. So I'm going to use a ruler to do that. Also, I recommend using a compass to draw your circles because I didn't, and it's interesting. So hopefully this will be kind of a straight line. Oh, that was a great sound. Okay, so we have our line AE, so we can just write AE, and this is because of postulate 1 or postulate fun, which says that you can take 2 points and connect them. La la la. Anyways, on to step 3. So for step 3, we're actually going to draw another circle, which again, I recommend a compass because you can, 2 reasons. You can measure the exact length of AE because we are drawing it from AE. So we're just going to take our line AE, and from it we're going to draw the circle AFG. So if you use a compass, you can find the exact length of this and draw your circle from it. But since I don't have a compass to use for this, I'm going to be drawing it just from the point A. And the second reason that I recommend using a compass is so your circle does not look like that, but it's okay. So the reason that we can do this is because of Book 1, definitions 15 and 17. Definition 17 talks about what diameter is, and definition 15 talks about the definition of a circle. So we now have our circle. So then our fourth step is we are going to take this point D, and from it we are going to draw a line to make line DF, and we are going to draw this line at a right angle to our line that we already have, AE. So we're going to take this point, and then we're just going to draw our point F, and then point G for the circle is down here, and it doesn't really do much, kind of like point C, so they're just kind of like chilling together, not really doing much, but that's okay. So then I'm just going to write that it's a right angle right there just because it becomes important later and that'll help remind us. But basically from point D, we get line FD, which is at a right angle with line EA. And that's an at sign. So if it doesn't look like that, that's what it is. And so the reason for this is Book 1, Proposition 11. And Proposition 11 says to draw a line from a line you already have. So A is a line we already have, and you draw another straight line at a right angle to that line, which is what we just did. Okay, so the next thing that we're going to do is we're going to use postulate 1 again. So we're going to connect the dots. La la la. Alright, so postulate 1. And we're going to use postulate 1 to connect the points FE. Oh, okay. Sorry, I have to redraw my point B, which is definitely kind of cheating, but it's okay. I mean, it's not really cheating. I just didn't draw where it's supposed to be because it's kind of supposed to be right there. But anyways, now it's fixed. And then the next thing we're going to connect is points A and points B to create our line AB. That is not a super straight line. Sorry. So there we go. Okay. Oh dear. Now you can see why my circles look the way they do, but that's okay. So we just connected AB and FE using postulate 1. So then the next thing that we are going to do, okay, actually, so I'm going to erase this and start writing my other stuff. So we are done with our construction, and now we are going to get into proving it. So I'm just going to erase this really quick so we can have everything for our proof in one spot. So we're moving on to number 6, hopefully, if I'm on the wrong step. I apologize, but the next thing that we're going to do for 6 is reestablish that E is the center of our circle. So point E is the center of circle BCD, but it is also now the center of our new circle AFG, so we can just write that down as well. Oh, okay. And you don't necessarily have to restate this step, but I just like to do it because it helps me kind of remember things. So the reason for this is just statement 1, because we're just restating something we've already said. So the next thing that we are going to do is we're going to pull out the two triangles that we have. So we have the triangle FDE and we have the triangle ABE. We're going to pull them out because we are going to start marking some of the sides on them as equal, so it just helps if you can see it. So I'm just going to draw those very quickly. So we have this one. Okay. And then ABE. And they're a little bit smaller than our actual triangles, so they're not necessarily drawn to scale, but they're just kind of to help us show our sides and everything. So the next thing that we're going to do is we're going to use definition 15, which is the definition of a circle from book 1. And we are going to use this definition to prove that some of the sides of these triangles are equal, because definition 15 says that if you draw a line from the center of a circle, which is E, that's kind of why we restated that. Well, not kind of why, it is why. But because if you draw a line from the center of a circle to any part of the outside of the circle, it is equal to any other lines drawn from the center of the circle, because they're all coming from the same place. So with this, we can say that FE is equal to AE. We can also say that FE is equal to ED. And we can also say that BE is equal to ED. So we can write some of this out on our triangles that we have. So we're going to say, we're going to use BE is equal to ED. And we are also going to use that AE is equal to FE. We don't necessarily need to say all the sides are equal, we just need 2 of the sides. And then the next thing that we are going to do is we are going to say that angle E is common. And what this means is that if you look at the triangles, you have angle E on both of them. And saying E is common is the same thing as saying angle E is equal to angle E. And so what we realize with this is that we have side angle side, which is proposition 4 from book 1. So with this, we can also say a few other things that I'm not going to write down on the triangles, but we can write out in our work. So we can also say that BA, the base BA is equal to the base FD. And we can also say angle EFD is equal to angle can also say that angle EDF is equal to angle EBA. So we've established that our angles are equal, our sides are equal, and we mark some of them to prove side angle side, and then these are just some other ones that end up being equal that he kind of talks about. So then the next thing that we're going to do is we are going to look up at our picture and remember something that we wrote earlier. We said that EDF is a right angle, and so we have that angle right here, and we're saying that that angle is equal to angle EBA, which because of common notion 1, which is from book 1, and it says essentially equals are equals to equals. So basically it says that things are equal to each other, equal the things that the thing it is equal to equal. That's super confusing, but basically it says since EDF is equal to right angles and it's also equal to angle EBA, that means EBA is also equal to a right angle. So we can just kind of restate that. We can say angle EDF is equal to a right angle, therefore angle EBA is equal to a right angle. So the reason it's important to have the right angle, to remember that right angle, is because in proposition 16, the porism, I think it's pronounced that way, but if it's not, then I'm sorry that I'm pronouncing it completely wrong. But in that proposition, it says that a straight line drawn at right angles to the diameter of a circle, from it, the extremity of it touches the circle. So if we look at the things that we've written, it says that we can establish that EB is the radius, but furthermore from that, we can establish that, sorry, we're actually not going to write that yet. I don't know why I'm saying establish so much, but we can say that if we look at it, we drew DF at a right angle to AE, and then earlier we said that FD is equal to BA, and so that would also mean that BA is at a right angle to AE, which we also said when we said that this angle is also equal to a right angle, meaning that AB touches circle BCD, because that is what it says in the porism, I believe it is pronounced, in proposition 16. So he establishes that EB is the radius, and then he goes on to say that from book 3, proposition 16, porism, we can say that line AB touches circle BCD, and that is the end of our proof and proposition 17. So I hope that helped and made sense.